and we're gonna start building each component one at a time. Okay, so first what we need to do, right, is general layout. So we need to create a header object, and that's gonna be a dashboard header. And for now, I'm just gonna create it, and it's gonna be empty. We need a sidebar. We store it in an object called sidebar. Okay, and then we need a body. I'm going to store an object called body. And then we need to create the overall UI is a whole dashboard page, which combines the header, sidebar, and body. Okay, and then down below, we need this line of code to actually run the app. And it takes in the UI above and the server, which is in the servers function. Now to run an app, you either click run app, or you on Mac, you can hit the shortcut Command-Shift-S. Okay, so yeah, here we see, here's a header, here's a sidebar, and of course here's the body. So what we're gonna do to this header is we're gonna add a title. So the way to add objects or specific components to a certain layout object is you pass it in as parameters. So here we're going to say title equals, and then title, modular arithmetic. And then we're going to rerun the app. And now you see the title here is rendered modular arithmetic. Yeah, so what's unique, I guess, about this our Shiny app is when you render objects, you render specific objects, you pass them as parameters to these functions, and you also combine them with existing parameters such as title width. If we want to set the title width to 400, I think that's pixels, then we see it changes to 400. So we separated these by commas. If we have a lot of objects, it can start to get kind of cluttered, if later. So usually what I like to do is I like to separate them all on different lines. But when you do this, be sure to remember you always have to have a comma between these arguments because they're arguments to the dashboard header function. Okay, so now we're going to create the sidebar. Some main parameters of the sidebar. Let's see. First of all, disable. It says if you want to disable it or not. So we set disable true. There's no sidebar. But here we're going to set disable false. Okay, now I'm going to pass other objects to put in the sidebar as other parameters. So we want to put plain text. We stick like H4 and we write the text. Here is the sidebar. So this H4, it might seem kind of arbitrary, but for those of you who know HTML, H4 renders like the fourth biggest text header. So you can change these. You can change the value of this number to make the text bigger or smaller. Here when we re-render it, we see here's a sidebar. And of course, this line gets pretty long. So again, I'm going to split it onto different lines.
Is there a library or something you have to input in order to use HTML code in R, or is it automatically built into like the language R itself?
Yeah, that's a good question. So actually, there's a couple things like H4, H1, like the header styles that are right into R. But if you want to use more niche HTML functions, I'll show you how to, or CSS. I'll show you how to import a CSS tag into certain text. But yeah, there are ways to, you add like tags to certain objects and it will like render as HTML or CSS and stuff. Actually, John Sebastian here, I don't know if he's still here, but he figured out a way to get his whole HTML and CSS JavaScript program, like pass arguments to and from.
Yeah, you can communicate between JavaScript and our Shiny, and you can include HTML, which has scripts inside of it. So yeah.
Yeah. So Yeah, so there's definitely ways to do that. Okay, so now we're gonna start with now we're gonna get started on adding stuff to this body. So notice here in this other app, how is this body set up? So here up here, like for example, we have a box, and within these boxes, but also here, notice that you can see like you can see this kind of imaginary column line as if like everything were like aligned on one column or like on one row. So yeah, so in our Shiny, you can create what's called fluid rows and columns and boxes, um, which basically separate out things and put them into appropriate locations aligned, even though there's no like physical row or column lines put in here. Now we're gonna go back to our new app that we're creating. So in this body, one thing we can add is a box. Here you see a box. Within the box, we want to make it bigger, so we set the width. I think the width goes from like 1 to 8, and the height goes from I think like 1 to 1,000. So here's a bigger box. But notice if we change the size of the screen, it changes. So we want to set like a default width to cover the whole screen. We just set width equals null. Okay, so now within this box, I'm going to create a fluid row, and within that row, I'm going to create a column. Okay, and you'll see in a moment how these are set up. So I'm going to add some text to show you where these rows and columns actually line up. So here is row 1, column 1, and oops. Oh, right, in a column, right, we need a width. Okay, so here's row 1, column 1. Now, if we add another column, that's column 2. We see this column is separated here by the width, and if we add another fluid row, let's see, with row 2, column 1, row. Okay, we can see these displayed in like with we can imagine arbitrary imaginary row lines and column lines so aligned. I guess my advice is always to like always to check your output by running the app. I mean, of course, it's entirely possible to set the layout by just memorizing the code for it, but I think especially with layout, I mean, I don't even remember all the specific widths or heights or different types of alignments you can put. So the best thing to do is just test it. So now in our actual app, we actually don't want to put it in this box. We're just putting on this general thing. So I'm going to get rid of the whole box. Okay, there we go. I'm going to start from scratch. So we actually have, in the app, I don't even remember, we had 2 columns. One is here, the operations, you input, the equations here, and then the tables on the bottom. What I'm going to do is I'm going to create a fluid row with the stuff here, and we're going to create one column that says here are the operations. We're going to stick that in H4 tag. Another column here. Let's see, here is the resulting equation. Oh, right, I always forget we need to set a column width. And those are parameters, so we need to separate them by columns. Now here you see the imaginary columns drawn. Now on the bottom, right, we have the multiplication tables. So what I'm going to do is I'm going to create another row. And I'm going to say, Okay, here's the multiplication table. And finally, we're going to create another one that says, here's the addition table. Okay. So now so it's kind of hard to see, but if you can imagine, this right here is going to be the operations, the equations, multiplication table, and addition table. Okay, so now we got our layout all set. Now let's start adding some objects. So I guess, right, the first thing you learn how to do in any CS class, I just said this last week, is you print hello. So we're gonna make a text input here, and a little button that says, and then when you click the button, it prints hello world. Okay, so what we're gonna do is, we want it in this column here. So we're gonna go to this specific column, and we're gonna make a little widget. It's a text input, and it has all these arguments, input ID. This is going to be anything like message, the label, type text here. And as you see, there are these other default values that are optional. I think those are just formatting, so I'm actually not going to leave those empty. So now we see this little text input object displayed right here. So notice the difference between input ID and the label. So actually, if I create another, I'm going to create a button. It's called action button, input ID, print button. Right. Also, these are arbitrary ID names. You can make them whatever you want. Okay, so the input ID, that's the ID that we give to this object that we're going to pass to the server. And that's how we access the information that's in here in the computer. The label is what's actually going to be labeled, how this can be labeled. So text input, it labels it here. The button, it labels it on the button. Now when we hit this print button, right, or when we type anything in here, nothing happens, right, because we didn't create any server functions that respond to the user input. So what do we want? We want, when it says hello world, when we say print, we want it to print right here. So if you want to create a text that's dynamic, you write UI output, and the output ID is right. So notice this is different from just an H4 tag. So notice when we write UI output right here, it doesn't render anything because it defaults as null. So now we're going to write server functions that when you hit print, it's going to take the text string in here and pass it to this UI output and print it out right here below. So actually, let's go down to, let's jump right here to the server function, and we're going to write a function that does that. Okay, so to handle event expressions, there's several different ways to do this. The standard way that I use and Karina does and Paul showed us how to do is using this observe event. So first you put what is actually changing. So when we click the button, so we want to say input the button. This is where the ID comes in, right? There's lots of buttons, you know, there we tag them by IDs. So we call this button print button. So now we pass in print button and write as follows. So what this is going to do is say, when you click this print button, it's going to call this function. So now what do we want to do this function? We want to render the output to here. So first of all, we say this message. We want to take this message from here. This message is stored in this text input labeled by input ID message. So it's actually stored in the set of inputs. And you should extract it by using this input $message. So now we can say print message, and then we'll see what happens when we. Okay, so when we print this message, inside R, it knows that this message is hello world now. So we're passing it here. When you print it, it literally prints it to the console itself within R. Now we want to pass this back out to this output, right? This UI output. And this output is tagged by output text. So what we're going to do is output. We want the output. What do we call it? We called it output text. Rendered UI. We want to render message. Okay, so now we have hello world, and voila, it prints out hello world. On the left side, for these operations, we had a set of widgets. So we're going to start creating these widgets under this column. So I wrote some little notes here for me. I have the first thing I have on the top is a checkbox input. It might seem kind of arbitrary that I memorized all these random widget functions, but actually our Shiny Widgets has a website that contains all the types of widgets and the code for them. So one of those types is a checkbox input. Checkbox input. Let's see the ID. We're going to call this. This is the primes checkbox. So label is primes only. Value. I think usually when you have a value in these widgets, it means set the default value. So this is checked or unchecked. So it's true or false. I'm going to set it unchecked and see what happens. So there's the primes. Notice nothing happens, right? Because of course, because we didn't write any server functions that actually does anything. Now I'm going to create a slider. This is the modular, right? It's called n. The label is also going to be n. Notice usually the input ID and the labels are the same, so don't get confused by them. But the minimum value of the slider is 2. The maximum value is 50. The default value is going to be 2. Here we have this nice looking sliders. Notice how they're like hundreds of parameters. You know, like one of them is like ticks. You have like ticks are true or false. Like they're optional parameters you can add in. I think the ticks here is useful for seeing specific values. Now we're going to have a numeric input. Numeric input. This is the first value. This is the x value. A label. Label equals. Actually, I'll just call this x. Label. We're also going to call this x. And we're going to set this value, default value 0. So here's the numeric input. It's like the text input, except it only has numbers in it. We're going to set another one for y. This is like the right side. And we're going to set, radio buttons. These are those like multiple choice buttons. This one's a little bit more involved, but not too bad. These are operations. I'm going to label this operations. Okay, and now here we have a choices. You can store your choices in any data structure you want. I usually store them in a vector. So the choices we have are plus, and I'm going to pass them in as vector, as a vector. Multiplying, division, exponentiation. And then we're going to say selected, the default selected. Let's say plus, and then see what happens. We want inline equals true. Okay, and then the next widget we're going to add is a simple action button that says, that's the compute button. So this is compute. Okay, and we should be all set, right, with making the apps. Now on the right side, we want, here's resulting equation. Yeah, that's good. Actually, we don't need this here, the operations. Now we want a dynamic text, right, that that only outputs equations after you hit compute. So what we're going to do is we're going to create a UI output, and output ID is, call that result. And of course it didn't compile because I didn't put commas between the parameter arguments. Okay, now below, here's the multiplication table. So we could have different types of outputs. There's UI output. Here we're going to use table output. It outputs things in a table format. ID equals, oops. We're going to call this multiplication table. And we're going to copy this in and call this addition table. Okay, now we don't see anything yet because these outputs default as null, but when we write server functions, we're going to pass in rendered forms of the tables into these, and it will run. All other outputs you can put a plot output. Plot output displays graphs. Okay, so now we have all our user interface objects set. Great, now let's start writing some server functions. So to write server functions, we're also going to need the functions that Karina just showed. So we're going to import it using source. And you just write source and the name of the function containing the file containing the functions. Also, make sure when you try to run this source that you always go to session, set working directory, and choose your directory, and make sure you choose the directory as the folder in which these two things are files are contained in. So now we're going to write some server functions. So here's a given server function already that Karina wrote, and she's going to show right after. It shows how to utilize the flex table to create nice tables. It's a little complicated, so I'm not gonna write it live right here. But it's nice that we have that array. So the first server function we want to write always is the initialize. So notice how we have these like UI outputs. These plot outputs are defaulted as null, but empty. But we actually want to initialize these plot outputs as a default plot. So we're going to write initialize, and the initial output is we're going to update to. We're going to initialize these tables to the 2x2 tables. Okay, so now we want to write a server function that responds to the event of computing. So we're going to say input. I think we label this compute button. Okay, so what do we want to do when we have this compute button? First, we take n. We're going to take our value of n. And we're going to take our value of the value inside these outputs. So this basically passes the values that are changed live by the user on here into variables I call and left value, right value, stored in R's global environment. Stored in R's global environment. So here we're going to have y, and we're going to have operation equals input operation. Okay, but here still when we write compute, nothing happens because we didn't actually put anything in here. So now what we want to do is we want to pass this output text, output result. We want to render UI. What do we want to render? We want to render convert equation of n operation, left value, right value. So now that when we hit compute, it outputs the equation. But of course, it's right now it's in LaTeX source format. So to change that, we're going to stick this in the with math JAX. Now when we hit compute, if you saw for a brief second, it passed in the LaTeX source code and it automatically compiled it into LaTeX. Okay, now what else do we want to pass in as user? So say like we want to say when we change this value of n, we want the multiplication tables to automatically change. So that what we're going to do is observe event. And what's changing here is the slider, so that's n. Input n. It doesn't matter when you're doing event handling, it doesn't matter what's actually inside these inputs. It just matters that it just calls this function whenever the inputs change. Okay, so we want to say when it changes, update tables to what's inside. And as we see when we move the slider, it re-renders them on the spot. Great, what else do we want to encode? We want to say when the user hits this primes button, what changes? These tables are changed. Well, first of all, when the primes buttons hit, we want this thing to move to the closest prime, and then we want the tables to re-render, and this equation to change. So we see observe event, input primes. Well, let's see, what did I call this? I call this primes. I call this primes. We want to say n is the current value. Primes is input primes. What prime is, that's the true or false value if it's ticked or not. And we want to say if prime, if it's checked. That means if prime is true. We're going to change n, not to what it is now, but what the closest prime. Closest prime n is right now is n. And we're going to set these default values. Okay, so now when we do it, when we have primes checked, when we check prime on and off, it should change this value of n. And we'll see. Actually, no, I'll just go to the next step. But when we recompile and we go to a composite number like 14, and we click primes only, it doesn't change. That's because n changed here, but we didn't pass it back here. So what we want to do is update the slider input session input the ID. It was n. We want to change the new value to n, and you can change the min and max, but we're not going to change it. So now here when we have a composite number like 10 and we hit primes only, it changes it automatically right here back on the app. But notice it only changes when you click this on and off. Like when you change n now to a composite number, it doesn't slide automatically in the nearest prime number. That's because this changing prime thing is only passed when we're checking the primes, right, in primes. We want to pass that also to n. So we can copy this actually. We want to say if prime, then change n to the closest prime, also update the slider thing. When we see here, we still see nothing changes, and that's because this prime here is a local variable inside these specific functions. So as you know from local variables, can only be accessed within specific functions. So if you want certain variables such as n or primes, I think these are important variables that can be accessed globally by all the objects and server functions that correspond to them. We're going to instantiate some global variables. So we're gonna set the default of n to 2. We're going to set prime as default false, and this left value default as 0, right value default as 0. And the operation, we're going to also default as plus. A small distinction we want to make. So when we go to like compute button, for example, when we have these variables declared n as input n and so on, with this normal arrow means that we're creating a new local variable that can only be accessed here. So this n right here is actually different from this global n. It might be hard to see, but yeah, that's the case. So we want to assign the global variable n from 2 to the new input. We do double arrows. So now every time we run these functions and it stores values from n or x to y, it's consistent across all the objects and all the server functions that correspond to different objects. And honestly, I think this is just like a good coding practice thing. It's completely optional, but it definitely helps your code. Let me go here and we hit primes only. It automatically moves it to the nearest prime. And when we move n to a composite value, it also moves it directly to the closest value. Now when we render, it renders equations here. And that is about it. I guess the last thing I'm going to show is these CSS tags. There are many different types of HTML and CSS tags that you can add. I'm just going to show you like the most common, because of course I can show you all the different cases right now. Okay, so what I'm going to do here is I'm going to add some CSS tags. Okay, so tags style. Right, so first what I'm going to do is we put a hashtag and see where the ID is. So what do we want to say? Let's make this like red or something. This is known by the output result. And then we're gonna just put our CSS in brackets. So one of them is color. So now when we compute this, the output is re-rendered with the CSS tag.